We have learned yesterday is the volume, like the units of volume. We have, again, metric volume units and capacity units. Okay, talk about two units. And then we talk about how do we calculate volume. So I said there's one particular group of objects can be calculated by uniform one way. So which one objects have uniform cross sector, like this shape, this shape, this shape, and other shape as well. If you cut that in one way and all the cross sector looks exactly the same, it's identical, then it's called a uniform cross sector objects. All that kind of objects can be calculated volume by one way, which is the area of the uniform cross sector times the height. So it's the top part and the bottom one, what is the height in between those two faces. So we calculate volume like cylinder, which will be base times height. The base will be this one because that's the uniform cross sector. And we have this shape prism, triangular prism. We calculate, like we treat the triangle as the base. We won't treat the rectangle as the base because rectangle is not the uniform cross sector. The triangle is. If you cut all parallel to the base, then you have all triangles, identical triangles. So it's the triangle's area times the height. Okay, this is not a straight shape. So the height you measure is not the slant height. What you talk about is the straight height. Okay, in between the two faces, what is the actual vertical height? And we have a shape like that. In this question, I'm talking about, well, when they draw three-dimension shape, the graph, the two-dimension graph is not looks exactly the same as what you draw into the, like on a piece of paper. So for that shape, it's actually this one. It's a square plus a quarter of the circle. Okay, it's a square plus a quarter of the circle. But here it looks like rhombus and like a sector, but they will label a 90 degree here. You know here is 90 degree, then here will be 90 degree as well, because they are the same line. Okay, 180 together, 90 and 90. It's a square and a quarter of the square. Okay, it's not a straight graph as well. Then the height will be 6 here. It's labeled for you. Normally the height will label for you. They won't ask you to find. Well, the worst situation will be they give you this length. Okay, they give you this length and also give you the 6. You need to figure out which one you will use. Okay, we use the vertical one. Okay, which is the 6. Okay, we find the area of the cross sector and then we times that by 6 to find the volume. So this one type of the objects. And for 6G, it's called pyramids and cones. Okay, this is another type of the shape objects. So for this one, we have uniform cross sector. For this one, we won't have uniform cross sector. Okay, if we don't have uniform cross sector, we can classify that as another group, which is all of those graphs. Okay, have a look at all of those graphs. What's the common thing? Like, can you tell me one thing in common? They are not uniform cross sector except that. What's one thing in common? They all going smaller, 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 and to a sharp point on the top. Okay, they all decrease like in straight lines and then meet at a point on the top. Okay, this one's the same. Like it's a triangular base, and it's all straight lines going up, and they all meet at a point here. Same as that one. Okay, it's a circle here, going up by straight lines and meet at that point. It will be different for this shape. I'll just draw another shape which is not belongs to that. Well, it's quite challenging to sketch three-dimensional graph. Let me have a think how I can sketch it. Well, hopefully it works. Oh, good, it works. Okay. So some shape like that is not uniform cross sector because it doesn't matter which way you're trying to slice that, cut that, it won't give you a uniform cross sector. But it also not belongs to those type. Okay, we have a wider base and it's all by straight line growing up, but it not meet at a point on the top. Okay, so this is not this type. Okay, this is not belongs to those type. Or if we have, let's say we have something like that. Okay, something like that. Well, it's not this type either. Even though they, well, just have an imagine, I don't know what is it. Like, it's like a peach, maybe. That's just that shape, like we have a circular base. And yes, it's growing up and they meet at a point. But it's not growing by straight lines. Okay, it's not straight. They need to be straight. All the lines needs to be straight and then meet at a point. This is not, it's curved. Okay, it's not straight lines. Then this is not those types. Okay, so now we have two types of graph. One type is we have uniform cross sector. And the other type is we don't have uniform cross sector, but from the base, all the lines going straight and going straight up meet at a point on the top. So you have a sharp point on the top. So the way we calculate this type of graph is, okay, is a third of the area of the base times height. Okay, is a third of the area of the base times height. So, okay, scientists or no, maybe mathematicians find out this. Okay, it's not me. I can show this by using a cylinder and a core and pulling waters into each other to show you this definition, but it's not a proper proof. So what the definition says is, okay, if you have two different objects, one object is a uniform cross-sector one, okay? They have a, like, just for example, we have a cylinder. We have a cylinder. Okay, and then, okay, we have a base of circle, which this circle has like radius of 2 and height of 10. And then we have another thing, which is a core. Okay, a core. This core has the same base. Okay, and have the same vertical height from the base to the point on the top. So we have a height of 10 as well. Okay. Okay, we have a core like this. What we can say is this cylinder and this core has the same base and same height. But one of that has uniform cross-sector, all the circle grow up in that way, and one has a sharp point on the top. But they still have the same base and same height. So the volume relationship is 3 times. Okay, this cylinder's volume is 3 times as that one. You can see that if they have the same base, same height, this one must have a bigger volume. Just think about when you pour waters in it. This can contain more water. Okay, so this one will contain less because if you complete this, that's the cylinder, okay? The red one is the identical cylinder to this one. Okay, this one is the identical cylinder to that. So definitely the core will contain less water, but the relationship is 3 times. Okay, 3 times. This is a third of that. So we can calculate the volume of the cylinder first and times that by a third, then you will get the volume of the core. It's not only this is true. I can draw a pyramid, a square pyramid, and a prism, like rectangular prism. Well, I can draw a square first. That is the square. That's the rectangular prism. And now I will sketch using red. Can you see a square pyramid here? Can you see the red one is a square pyramid? That square pyramid will be a third of the volume of the rectangular prism. So I will calculate the area of the square rectangular prism and times that by a third. And I will get the volume of the prism, the pyramid. Okay, so if one uniform cross-sector and another not uniform cross-sector but got a sharp point on the top, they will have volume of, if they have the same base and the same height, it will be a third of the relationship between the volume. Okay, so it's times a third. Other shape will be true as well. Okay, other shape will be true as well, not only those ones. Anything you can draw similar shape like that will be true. So let's just have a look at the questions below here. I'll just sketch the uniform cross-sector one for you. So that is a pyramid. Okay, that is a pyramid. So if I use red, sketch that. Okay, can you see that? That is the middle of the square here. So that's the relationship. Let's say I said a third of the relationship. So the uniform cross-sector shape of this graph will be a rectangular prism. It will be a rectangular prism. So the way I will calculate the volume of this pyramid will be, I will calculate the volume of the square rectangular prism first and then times by a third. So I will times 5 and 5 together, which is the area of the base, the square base, and times this by 6, which is the height, and I will times this by a third, which is the volume of the prism, the pyramid, not the prism, the pyramid. So it's 25 times 2, which give you 50 meter cube. 50 meter cube. Oh, yeah. The area is 5. Sorry. You are correct. The area is 5. It's not the length. It gives you the area already. So, yeah, my bad. You should read the question more clearly. So it's 5 times 2, which is 10. 10 meter cube. Yes, the area is given. Okay, next one. Next one, I will again sketch this first. I will sketch this. Okay, that's the top. Okay, something like that. What's the shape of this black thing? What is it? What object is that? Triangular prism. Okay, it's a triangular prism for this black thing. So if it's a triangular prism, I will calculate the base of this triangle first. Okay, this base of, well, my graph is quite bad. Let's look at the base. The base got 13 of this length and 15 for this height. So it's a half times 13 times 15 meters, which is the area of the base triangle. Okay, it's the area of the base triangle. And times that by 8, which is the height. Times this by 8, which give you the height. Okay, now we have calculated the triangular prism's volume. We have calculated the triangular prism's volume. And I'll times this by a third. Times that by a third. So that is the triangular prism. And here is the area of the triangle. Okay, the area of the triangle. So we will have, okay, that become 4, that become 5, that equals to 3 times 5 times 4. So if 13 times 20, that's 260 meter cube. Yeah. Oh, I have sketched. Yeah, 18. Yes, my lines overlap with that. So here will be a 9. Here will be a 9. So what's that? 65 times 9. Okay, that's 585 meter cube. Okay, last one. Last one is like a corn, but like it's not like a straight corn. Okay, it's inclined to that way. So it's the same way as a straight corn. Okay, it's the same volume as the straight one. So it's exactly the same way we calculate that. So we will do, okay, pi r squared, which is the area of the circle, times this by 6, which is the straight height. Okay, not the slant height, which is the straight height. And times that by a third, because that's not a uniform cross-sector objects. Okay, so we have that. That's 4 pi times 2. Okay, a third and 6 get 2. And that's 8 pi meter cube. And remember, that is the exact answer. Okay, do not try to do anything else. Okay, 8 pi is the exact answer. Do not 3.14, not going to apply to this question. Okay, so exact answer will include the pi if you talk about circle or something. So we will leave our answer like that. Okay, next one. Well, we finished we finish how do we calculate this type of graph's volume. Okay, how do we calculate those type of objects' volume? And the last formula we'll learn is the volume of a sphere. Okay, what's the surface area of a sphere? 4 pi r squared. Okay, 4 pi r squared. It's quite similar. We just divide that by 3 and r cubed. Okay, that's the volume. 4 over 3 pi r cubed. Okay, remember you need to memorize those two formula because year 11 you'll use those two formula. Maybe not year 11, but year 12 you will use that one. Yep. I think might be the notes allowed. I will double check and post on Google Classroom about the date and whether you can use Castle notes. Okay. For sphere, V equals to 4 over 3 pi r cubed. Very easy, just like that. Okay, what is R? R is the center of the sphere to the surface. Okay, the center to the sphere, which is here, and to the surface. Okay, all the radius will be the same. All the radius will be the same. It's all 0.5 in this question. So this question asks you to find the surface area and volume of the following sphere. So surface area equals to, it's quite hard to talk over you, 4 times pi times 0.5 squared. Okay, 4 pi r squared. Okay, as I said, this chapter is basically apply formula. Okay, apply formulas. So we can have 4 pi times, that's a half square, a quarter. I like to calculate everything in fraction, not in decimal, because I can easily make mistakes in decimals. So 0.5 is a half square is a quarter. So the surface area will be pi, meter square. Pi, meter square. Okay, volume is 4 over 3 pi r cubed. So which is 4 over 3 pi times a half cube. A half cube. Okay, that's 4 over 3 pi times 1 on 8. This 4 becomes 1, this 8 becomes 2. That is pi over 6 meter cubed. Those two answers are exact value. Okay, do not evaluate those two. Okay, do not try to evaluate those two. Is exact value. Pi and pi over 6 is the exact answer. Okay, I emphasize that a lot of times. On your test, read the question carefully. Is that asking you to put 2 decimal places or keep exact values? Keep exact, you need to involve the pi. Yep. Okay, if it doesn't say exact, it's required. Okay, like we need to keep everything exact unless state. Okay. So, for example, this question doesn't say anything. We need to keep exact. Okay, that's one circle, and have a look at next one. The next one is 0.92, but 0.92 is the diameter. Okay, D equals to 0.92 kilometers. That's the diameter. Therefore, radius will be 0.92 divided by 2, 0.46 kilometers. Well, that's 4 over 100. And I can divide by 2, that's 23 kilometers. I can put that in the fraction form. Well, it's still quite hard to calculate. Well, surface area is 4 pi r squared. So it's 23 over 50 times 23 over 50. Okay, this 4 can make 25 and 25 each. Okay, 2 cancel with 150 and another 2 cancel with another 50. So surface area is, okay, what's 23 squared? 23 times 23, 69, 46, 529. Okay, 529. So surface area equals to 529 pi over, okay, 25 squared, we know that, 625. 625. Okay, volume equals to 4 over 3 pi r cubed. So it's that and times another one. So this time this 4 will make 1 and that becomes 25, that becomes 25, but another 15 not going to have the cancel with that. So it's 23 cubed. 23 cubed, 12167. V equals to 12167 pi over 3 times 25 times 25. 3 times 25 squared, 1875. Okay, it's a quite complex number. It's kilometer cube. Yes, kilometer cube. Pi. Okay, I'll just do up to here today, and I will spend a little bit time next lesson to complete the limits of accuracy, and we finish this chapter. What you need to do now is do all the practice. Okay, do all the practice. You need to practice a lot on your textbook.